All right, let's remind ourselves how to write an equation of a line that's parallel or perpendicular to a given line. Let's go ahead and first review the two different forms of a linear equation that you can write. We have slope-intercept form, which is probably the one that we will use most often. It's also the one that most people are more comfortable with. Slope-intercept form is y equals our m x plus our b value. Remember that m is our slope, and slope-intercept form wouldn't be complete without our b, which is the intercept, y-intercept to be exact. Then we have point slope form, y minus, and it has a point in it, y1, and it equals, again, the slope, parentheses, x minus, and then there's the other part of the point, x1. Oops. And once again, we have m is slope, and point slope form wouldn't be complete without our point. So let's actually put these into use. I've got a couple of practice problems that have nothing to do with parallel and perpendicular. They're just everything to do with can you write an equation given some characteristics or some key points. So first we've been asked to write an equation of the line in slope-intercept form that goes through 5, -2, and has a slope of -3, 5. So if it has a slope of -3, 5, and it goes through a point, that means that I'm going to use point slope form to start out my equation. Now that's not what we want to end our equation in. We want it to end in slope-intercept form. But if they give you a point and they give you a slope, you might as well use point slope form. So we have y minus my y coordinate, -2, equals my slope, -3/5, and then x minus my x coordinate, which is +5. Okay, now we just have to make this into slope-intercept form. Well, what's the main difference between slope-intercept form and point slope form? The main difference is that slope-intercept form has no parentheses and has y by itself. So I guess two main differences. So let's distribute to get rid of the parentheses first. When we distribute this, the left side stays the same, minus -2, which we know really is positive, and -3/5 distributed to x is -3/5 x. -3/5 times -5 gives me +3. So I got rid of the parentheses. The only thing left to do is to get this y by itself. That's why we practice solving a literal equation. -2 from both sides. Y equals -3/5 x plus 1. It's in slope-intercept form. It goes through the point. It has that slope. What happens if they just give us 2 points? Well, if they give us 2 points, we need to be able to find the slope. You may have learned how to find slope using your your slope formula. That's okay if you still want to stick with that. I'm going to go back and use the table that we just talked about in the previous lesson. So we have our x and our y's. 2, -3 is the first point. -3, 7 is the second point. I get from 2 to -3 by going down 5. from -3 to 7 by going up 10. The y goes on top. 10 over -5. That reduces to a whopping -2. Or you could write it as -2 over 1 if you really want. So there's our slope. The only other information that they gave us was point. I'm just going to pick a point. It doesn't really matter which point. If you want to use 2, -3, you should still end up with the same final answer because we are going to go ahead and practice putting that back into slope-intercept form. Y minus our y coordinate, which is 7. And then it equals our slope, which we just found was -2, parentheses x minus my x coordinate, -3. So we're going to get rid of the parentheses first. -2 times x, -2x. -2 times this becomes a +3 is -6. Then we have to move the 7 to the other side. So we're going to add 7 to both sides. And y equals -2x plus 1. Flip it over. Now that we can write an equation given some key points, we need to talk about what it means to be parallel and perpendicular. So parallel lines, they don't intersect and they always have the same slope. That's very important information for us to know. They have the same exact slope. So if I were you, I would maybe highlight or underline that information to remind me later. Same slope. Perpendicular slopes, or perpendicular lines rather, are lines that intersect to form a 90-degree angle, and they have slopes that are opposite reciprocals. So let's put that into practice and write an equation that's in slope-intercept form. It passes through this point and is perpendicular to the line with this equation. Step 1, find the original slope. What was the original slope? The original slope came from this equation. The number in front of the x, that's my slope. Step 2, make that slope parallel or perpendicular. So we're going to take this, and we wanted it to be, in this case, perpendicular. So I'm going to make it positive 1 over 5. So that's the slope that I'm working with. This is the point I want it to go through. It's now exactly like what we just did on the previous page. So step 3 is to write your equation. So I have a point, I have a slope. I'm going to use point-slope form. Y minus my y coordinate. Here's my point. So my y coordinate is -2 equals my slope 1/5 parentheses x minus my x coordinate, which is 3. distribute that 1/5 to both. And I have y plus 2, because remember minus a negative, equals 1/5 x minus 3/5. Then we have to subtract 2 from both sides. Don't go panic on me yet because we have fractions. Let's practice doing fractions in our calculator. We're going to get comfortable with this calculator before we get to later on in the year when we do some functions that were not available to us on a scientific calculator. So to enter a fraction, we have negative 3, and just use the division button, divided by 5. So there's negative 3/5. I want to subtract 2. And it's going to give it to me as a decimal, but remember, we don't use decimals as our answers. We want to get in the habit of changing them back to fractions, and we do that by pressing Math. Remember, the Math button is right underneath Alpha. Math, and press Enter. It's option 1, and it'll spit out your fraction, negative 13/5. Next one. Write an equation in slope-intercept form for the line that is parallel to the graph of negative 8x minus 12 minus 2y, and it has a y-intercept of 4.5. Okay, the first step is we've got to find that original slope. Well, if I'm going to find the original slope, that means I got to get y by itself. So that means I'm going to add 12 to both sides. And then I'm going to divide by negative 2 all the way across. So I'm left with y equals positive 4x minus 6. So my original slope step 2, make that slope parallel or perpendicular. Well, I want parallel. So parallel slope is also 4 because it's the same slope. Now we're going to write our equation. Well, what information have I been given? I've got a slope and I've been given a y-intercept. So I can just jump straight into slope-intercept form. Y equals my slope times x plus my y-intercept. Forgot my plus sign. There's our equation. Last one. Find the slope of the line that passes through these 2 points and write an equation of a line that's perpendicular to that line that passes through 1, 1. Step 1, guys, find the original slope. So it passes through this, that means this has to give me the original slope. 4, 2, negative 2, negative 1 are my 2 points. 4 to negative 2 means I went down 6. 2 to negative 1 means I went down 3. The y goes on top. Why? Because I said so? Not really. It's because it's rise over run. Negative 3 over negative 6 becomes 1 over 2. So my original slope is 1 over 2. Step 2, make it parallel or perpendicular. Well, it wants perpendicular. So perpendicular slope would be negative, because opposite, and then the reciprocal, 2 over 1, or just 2. Negative 2, technically. Now let's write our equation. Well, the information that they gave me was they gave me a point, and I already have a slope. So point slope form it is. Y minus my y coordinate, which is 1, equals my slope and then parentheses x minus my x coordinate, which is also 1. So let's distribute. Y minus 1 equals negative 2x and positive 2. Now we just have to move that 1 to the other side by adding it. So I have y equals negative 2x plus 3. Now you can get started on your assignment.